Okay, so good morning. So today we are going to see the different types of the collectors, solar collectors with the reflectors and the different configuration of these collectors as well as the thermal energy storage system. So in last lecture we saw the evacuated tube type of collector in which there are two concentrating tubes are there and in between these two tubes vacuum is present. So the loss due to the reflection and refraction all those going to be decreases or minimized. So same type of collector. So these flat plate types of collectors. Okay, this one is the simple tube collector, simple flat plate tube collector. This one is the evacuated tube collector. So in these particular types of collectors, the temperature we got is generally the less than 100 degrees centigrade, right? Or it is near about 60 to 70 or 75 up to 75 degrees centigrade in the normal procedure or the normal working. If you want to increase the required temperature or the whatever the temperature we got in this uh, tube collectors, if you want to increase that temperature or if you want to increase the heat absorbed by the fluid, we have to use different types of the reflectors. So this is the simple evacuated tube type of collector, and to improve its performance, to improve the performance of the flat plate collector, we have to use the different types of the reflectors. Now we can use the different types of the reflector like the plain reflector we can use, or we can use the curved reflector. So those reflector we are going to see here. The main purpose or the function of this reflector is to get a maximum or the reflect the maximum amount of radiation on this particular flat plate collector. So in that case, the temperature attained by the fluid which is passing through that flat plate collector is going to be increases. Okay, so we can absorb or we can observe the temperature well above the 100 degrees centigrade by using those reflectors. So you can see here the first of all the flat plate collector with plain reflector. You can see here this one is the flat plate collector. You can see here, I will just highlight this one. This one is the flat plate collector. Okay, on this particular flat plate collector, these reflectors, flat reflectors are has been mounted. Okay, these are the flat reflectors. So when the rays or the radiation incident on this reflector, it will get reflected towards the flat plate collector. So that is the main function of the reflector. And you can see on the right hand side, you will see the schematic of this reflector. You can, these are the solar radiation. You can see those are the just making 90-degree angle or the normal to this flat plate collector surface. And when those are going to incident on this reflected, what will happen? It will just reflected by an angle, and it will going to incident on flat plate collector. So that's how the more and more radiation which is coming from the sun, it is going to be reflected towards the flat plate collector, and we will get the maximum temperature or of that particular fluid which is passing through that collector. So these are the different types, different collectors are there. Plane reflector we are considering, these are the plane reflector because the shape of this reflector is the plane one. Okay. So now for this, the most important is that these radiations coming from the sun, it must be, those rays must be normal to this flat plate collector. Okay. So when those normal to the flat plate collector and when those incident on the reflector, in that case only it will going to be reflected with a certain angle to the collectors. If it will making some angle in that case or up in particular range only, it will going to reflect on the collector. Otherwise, it will does not going to reflect on the collector. So in the case of reflectors, if you want to install the reflectors, the necessary condition or necessary device we require, that is the solar tracking device. So solar tracking device, as the name indicated, it will track the sun. Okay, it will ensure this particular flat plate, it will going to be a normal to the sun radiation. Means angle between the radiation or the rays coming from the sun and the flat plate must be the 90 degrees centigrade. So that is the for that we require the solar tracking device. Okay, this one is the solar tracking device required in this in the case of reflectors. You can see different types of the arrangement also. Okay, generally the water heater or the flat plate collector we will saw, it will install it at some angle. Okay, and it will having the tube, and those flat plate collectors again install these flat reflectors are again installed with respect to the flat plate collector. So whatever the sun rays striking the collectors or the reflectors, it will going to be reflect and going to incident on the flat plate collector. So main function, understand the main function, because if you only install this flat plate collector, only this box, we will get the whatever the radiations coming from the sun, direct radiations, and those are incident on the collector directly. Those radiation or the heat from those radiation is only collected or only utilized in this particular collector. Okay, whatever the heat incident or the which is the diffused radiation, it does not going to contribute much amount of radiation or the heat transferred to that flat plate collector. Okay, so you will see the radiation must be a 90-degree or the must be the normal to the flat plate collector. Okay, and when we apply or when we install the reflector, particularly the plane reflector, in that case you will see whatever the radiation incident on this plane reflected will going to be reflected towards the collector, and collector will collect that radiation or the heat from the radiation, and we will get the or we will achieve more temperature or the more heat flux from that particular fluid, or which the fluid which is passing through this flat plate collector. Similar way, you will see the different arrangements are there. Okay, sometimes we are using the parabolic reflectors. Okay, the parabolic reflectors, or sometimes we are using concentrators to concentrate the radiation, large amount of radiation on that one particular surface. So in all those reflectors, the one particular concept is most important, that is known as the concentration ratio. Okay, so there are many types of different types of the configurations, different types of the constructions are there, or the concentrators are there, ranging from the plain one, flat one, to the cylindrical one, or to the circular that will focus on one particular point. Okay, so the main purpose of this configuration or these particular types of reflectors are to increase the radiation flux on the receiver. Okay, to increase the amount of radiation incident on the reflected. So in that indirectly it will we can achieve more and more temperature of that fluid. Okay, whatever the fluid passing through that reflector, passing through that collector, the effect is achieved through the reflection of the light from the multiple angles and curved mirror surfaces. Okay, so the main concept or the particularly basic point we should know regarding this reflector, different types of the reflectors, is characteristics which is showed by the concentration ratio. Okay, it will indicated by the concentration ratio, and it is indicated by C. Now, what is concentration ratio? So, it is the ratio of the factor by which the incident energy flux is optically enhanced on the receiving surface. Okay, means if we saw algebraically, the concentration ratio is equal to the radiation incident on that particular surface, or sorry, radiation which is going to be incident on the surface. Okay, it is the total radiation divided by direct radiation on the receiver. Okay, direct radiation on the receiver, total radiation on the receiver divided by direct radiation on receiver, means what? If you saw receiver having some area AR, okay, and the radiation incident on the receiver, it is the it will be the very similar, or it will be in the relationship with the area. How much will be the area, that much of direct radiation is going to be incident on this receiver. Whereas if we use the concentrators or if we use the reflectors, in that case more radiation will incident on the receiver than previous case. Okay, if he doesn't use the concentrator, so that particular ratio, or sometimes geometrically if you saw, we are using the areas of reflector and the concentrator or the receiver to define this concentration ratio. Similarly, we can define the concentration ratio as area of concentrator divided by area of receiver. Area of receiver. If you saw here, the concentrator area is more than the receiver area, definitely. So the concentration ratio will be greater than, always will be greater than 1. Okay, it will be the 1 or greater than 1. If he doesn't use any concentrator If you only use the flat plate collector, in that case, the concentration ratio will be 1. Okay, because the concentrator doesn't have any area, so it will be the one, only one. And if we are using the concentrator or the reflector, in that case, the area of concentrator or the reflector is much more than the receiver area, or the total area divided by the receiver area. So it will always going to be greater than 1. The if the concentration ratio is more than the 1, it means that the radiation which is received by the receiver, it will be the more than the direct radiation received by the receiver. Okay, so the main purpose of this parabolic or the flat reflectors or the concentrator is to increase the radiation flux on the receiver. Okay, that is the alternate aim. So if you increase the radiation, which are the received radiation flux which are going to be received by the receiver, means that we will get the more and more temperature of the fluid which is passing through the receiver. Okay, so that will going to be increase the performance, overall performance of the receiver, and that will be very beneficial to use that fluid for the many types of applications. Because in many cases we require the fluid which should have the more and more temperature. In the case of water, consider in the case of water, the heated water, we generally require the water which is having more and more temperature. Okay, it is near to the 100 degree or sometimes greater than the 100 degree centigrade. So to generate the steam or to having the heated water, we require this. If you use those collectors, only collectors, we cannot gauge that much of temperature, because if you use single flat plate collector, in that case we will achieve the temperature of water which is near about 60 to 70 degrees centigrade. If you want more temperature, we have to use the concentrators or reflectors to increase the temperature value of that fluid. So this is the main reason, that's why we are using the concentrators or the reflectors. Now the main requirement of these type of reflectors. Okay, so main requirement is the solar tracking device, because if you saw day by day, during the day or during the particular year, the position of sun in the sky is going to be changed with respect to the position of receiver, and in that case we cannot are able to maintain the direction of this particular rays directly or perpendicular or the normal to the receiver. In that case, we require the solar tracking device. Okay, so it will ensure this receiver or this particular receiver or these particular concentrators or the reflectors will have the radiation normal to that surface. Okay, it must be normal to that particular surface. So for that, we require the solar tracking device. Okay, so which will track the solar, and it will ensure that the radiation incident on the reflector or concentrator or the receiver, it will be the normal to that particular surface. Okay, now this solar tracking device doesn't require in each and every application. Okay, it is depends upon which type of reflector we are using. In compound parabolic reflector, we doesn't require solar tracking device. Whereas in this plain plane or the flat plate collector with the plane reflector, we require the tracking device or the tracking the system. Okay, so the different types of configuration also you can see in this particular diagram, whereas these circles or these are the tubes and through which the water is flowing or the working fluid is going to be flow, and you will see the different types of the concentrators or the reflectors are there. Okay, in the B, in figure A, you will see there is a normal flat plate collector. It doesn't have any reflector. A reflector will be at the bottom side of this tube. So when whatever the radiation incident on this particular backside reflected, it will be the reflected toward the this particular tube. Okay. Similarly, the shapes are going to be changed. It will be the curve shape. You can see the in the diagram C, there will be a tubular absorber with the a specular curve type of reflector, then the figure C will indicate shows you the plane receiver with the plane reflector or the flat reflector. The diagram D, you will see there will be a plane type of reflector, but it will having the multi-sectional planar concentrator. Okay, it will having multiple sections. Okay, so this one is say a different section, this one is a different section, this one is a different section. Now, how you will see in the figure D, whereas having multi-sectional reflectors, the angles of this reflector is going to be changed. Okay, this first reflector having the different angles, second reflector having different angle, third reflector is having different angle. Now, this angle has been set by using the to achieve the perfect reflection. Okay, if we are using same angle, in that case, consider there is one another one reflector. Okay, and it is having the same angle as that of first reflector. In that case, what will happen, whatever the radiation incident here, it does not going to be reflected towards the flat plate collector. Okay, so that's why what we do, the section here, from here we are changing the angle, so that whatever the radiation incident on this reflector, it will be reflected towards the collector. Okay, not away from the collector. So by using, we have to consider those reflection rays angles, incident angle, etc. And by using those angles, or by studying that particular geometry, we have to decide the shape of reflector. Similarly, diagram E, you will see that one is the compound parabolic concentrator. Okay, this is a compound parabolic concentrator. So in this case, it doesn't require solar tracking device. Whenever the uh, radiation coming in any angle, it will going to be reflected towards the this particular this particular collector. Okay, so it doesn't require any solar tracking device. Whatever the angle this particular radiation will make with this particular or incident on that particular parabolic concentrator, it will going to be reflected towards the collector. Okay, so in the previous one, you can see the radiation must be a perpendicular. Okay, it will be the perpendicular to the receiver. Whereas in the case of parabolic collectors or the compound parabolic collector, it doesn't require that angle of the radiation doesn't going to be affect the performance. Okay, so the intensity may be vary, but that variation is very less. Whatever the angle that particular radiation makes, it will going to be reflected towards the flat plate collector. So this is known as the compound parabolic collector or the compound parabolic concentrator. Now next one you can see again the parabolic trough type of collector. Whereas there is a parabolic reflector is there, okay, and at the focal point, okay, or the focal point you will see there is a tube mounted. Okay, so if you saw the parabolic collector is like this, and the tube is mounted on that particular focal length. So the rays or the radiation incident on this parabola, it will be concentrated at the focal length, its focal length. So the more and more radiation will concentrate here, and that at that particular focal point, the tube is has been passed. So the radiation or radiation incident on that tube, and it will be the heat will be transferred to the working fluid. Okay. So again, G and EH, these are the different types of the concentrators or the reflectors are there. G is known as a Fresnel concentrator, okay, and EH is known as the array reflector or the heliostat type of concentrator, which is having the central receiver. Now I will show you the actual diagrams of the heliostat and the Fresnel concentrators in the coming slide. Okay, so okay, so here what will happen in this figure G and figure H, you will see the Fresnel type of concentrator and the heliostat type of a concentrator. Now, Fresnel type of concentrator means what? In this trough type of concentrator, there is a parabola, okay, in the x-axis, and on the focal line, you are going to install the tube. Whereas in this type of Fresnel type of concentrators and the heliostat type of concentrators, there will be a pointed, we doesn't use any tube. Okay, there will be a pointed there is a one point is there. On that particular point, whole radiation is going to be concentrated. Okay. Whereas in the TRUB type of collector, the the radiation will be concentrated on the line which is passing through the focal. Whereas in the case of Fresnel and the heliostat type of concentrator, the radiation is concentrated at one particular point. Okay, so that's how there is a change is there. Okay, in the case of Fresnel and the heliostat type of concentrator, we will achieve very high temperature. It is near about, it is sometimes near about 350 degrees centigrade or more than that. Okay, because the whole radiation is concentrated at single point. Okay, and because of that, the heat or the heat generated or the heat concentrated at that particular point is very high. Okay, so in the applications where we required more temperature, in that case we are using this Fresnel type of concentrators or the heliostat type of concentrators. The compound parabolic collector. So these are the one of the important ones because as we know in the normal reflector, flat plate type of reflector or the parabolic type of simple parabolic type of collectors or the reflectors, we require solar tracking device. Whereas in compound parabolic collector, we doesn't require any type of solar tracking device. Okay, so if you see here, this will be the focal of the focal point of this compound parabolic collector. Compound parabolic collector means what? There are two parabolas are there. Okay. On the right hand side, you will see one parabola. Okay. This particular reflector is of section of one parabola, and other reflector is it is the shape of or the section of another parabola. Okay. And that's why it is called as a compound parabolic collector. In that case, we doesn't require any solar tracking device because with whatever the angle that radiation will making, it will going to be concentrated at the focal point. Okay, so if you consider the radiation is coming in this particular angle, okay, whatever be the angle, it will going to be reflected towards the focal point. Similarly, radiation coming from this direction, it will going to be reflected to the focal point. So the radiation incident angle of the radiation doesn't going to be affect the working of this collector. Okay, whatever the incident angle, it is going to be concentrated at the focal point. Now again we have to take care of this particular height of this collector because the sun will be traveled from east to the west. So in that case, we have to study that particular position of the sun, and by using that, we have to consider or we have to design the height and other dimensions of the compound parabolic collector. So basically, it doesn't require any solar tracking system. Whereas the previous collectors, if you saw the previous collectors, particularly these flat collector or parabolic collectors, these particularly parabolic collectors or these Fresnel or heliostat type of collector, it does require solar tracking device. Okay, it does require solar tracking device, and the main advantage of this compound parabolic collector is that it doesn't require any solar tracking device. Okay, you can see there is actually installment of the CPC compound parabolic collectors. These are the different collectors are there, and you will see there is a one line, okay, or the or particularly it has been at focal point or the concentrator on the bottom side. You can see this one is a model of compound parabolic collector. Okay, the focal point will be like at this particular line. So whatever the radiation incident, it will going to be reflected toward the collector or to that particular focal point. Okay, and you can see there is in this particular compound parabolic collector, with comparison to the normal flat plate collector, more temperature will we can attain the more temperature, more heat will be concentrated, and more heat flux or the heat will be stored or the collected by using the CPC. Now, another type of collector is there, which is known as the concentrating paraboloid collector. Okay, so you can see the schematic of this paraboloid collector. The main collector or the point where the all radiation incident on this collector has been concentrated. It is this one is the point, and at that particular point we install the receiver. Okay, so you can see whatever the radiation incident on this, whenever the radiation incident on this paraboloid collector, it will be the concentrated at this focal point. Okay, so you can see this is the actual installment of the paraboloid collector when this radiation incident on this receiver on this collector, it will reflect it toward the center. Okay, so at the center we are circulating the water or that one particular working fluid, which will always take the heat from this point. Okay, in this paraboloid type of collector, we achieve maximum temperature, which is far near about 300 or more than the 300 degrees centigrade. Okay, but here the main importance is that we require the solar tracking device. Okay, because in this case the radiation which are incident on these concentrators or the collector must be in the normal direction. Okay, it should be a normal direction. Then and then only it will be concentrate on this particular point. So that we require the solar tracking device. You can see here the different components of the parabolic collector. There will be a concentrator, a receiver is there, then the declination angle instrument is there, supporting base is there, counterweight we have to install, then the polar drive jack screw is there, declination drive jack screw is there, polar axis is there. So by using these mechanisms, we can the solar tracker is working by using that mechanism. It will track the sun so that the radiation coming from the sun it will be in a normal direction to this collector collector plane. Okay, so this is known as a concentrator solar in or the concentrating paraboloid type of collector. So these are the different types of collectors we are using to improve the performance or whatever the temperature we get in the solar collector or the simple uh, solar flat plate collector. Okay, so these are help to improve the efficiency. It will help to improve the performance, and we will get the more and more temperature of the working fluid by using those collectors. So the next point, that is the thermal energy storage system. Here it will only have some introduction to the thermal energy storage system. Particularly, as we know, the sun is only available during the daytime, and it will always the radiation coming from the sun is again changes with respect to the day, the timing in the time in the day, and also it will going to be vary around the year. So at the night, during the night, it doesn't have or it doesn't have the sun or the radiations from the sun. Also, the sun radiation is affected by the weather conditions, right? Weather conditions, locations, and etc. So we cannot use that energy or we cannot achieve the energy, get that solar energy all around the day and night. So for that, what we do, we have to store that thermal energy, right? Because whenever the radiation incident, it will convert it into the thermal energy or the heat energy. And if you want to use that heat energy during the night time, we have to store it. And for that, we can design the thermal energy storage system. So here what we do, we store the thermal energy in the form of sensible heat or the latent heat, and we can use that heat stored thermal energy later on during the night time or whenever there is a cloudy weather is there. So for that, we design this different types of thermal energy storage systems. Particularly, these systems has been classified into two types: sensible heat storage system and latent heat storage system. Now, sensible heat storage system means what? Here, the the heat energy or the thermal energy is stored by changing the temperature of working fluid. Okay, so here we are changing the temperature of working fluid, and it doesn't change any phase. Okay, the phase will be the same. Phase doesn't going to be changed. We just increase the temperature of that working fluid, and we are in that sensible heat. We store the thermal energy. Whereas in the latent heat storage system, we doesn't change the we are storing the thermal energy by changing the phase of the working fluid. Okay, so here we are changing the phase of the working fluid. We are converting that working fluid from liquid to the gas, or from solid to the gas. Particularly, we are using solid and liquid arrangement, because for storing the gas, we require very high volume. The specific volume of the gases is very high. So in that case, we are mostly using solid liquid phase transition than the liquid and gas transition. Okay, so it is known as the latency storage system. So these type of storage, sometimes we are using combination of these two. Okay. So by using that, during daytime, what we do, we are store the energy which is received by the collector from the sun, and during the night time, we are using that stored energy. Okay, and these type of thermal energy storage systems are mostly used for the heating purpose. Okay, not for power generation. This less used for the power generation. Okay, but mostly it is used for the heating purposes, heating to maintain the temperature of the houses and all those things. So sometimes it is also used for in the case of solar dryers, or to dry the different food products, etc. So these are the called as the thermal energy storage system. So I will share one PDF or the notes of this thermal energy storage system. You will just read those one. It is a simple types of systems are there. Okay, by using different arrangements or different systems, you can store the energy in the form of thermal energy, and you can use that during the night time. Okay, so these are the 2 points we covered. In the next coming lectures, we are going to cover the principles of PV cells. Okay, how it is working. Then what are the materials of the PV cells, cell module array, then its connections, and the particular design of standalone system with battery and the AC and DC. So these points we are going to in the coming lecture. So that's it. We will stop here. So just study regarding the collectors, different types of the collectors, how the performance is increased, and also the thermal energy storage.